plutonium. Plutonium is a heavy, silvery gray radioactive metal. It is dense, roughly 20 times heavier than water, and it can exist in several crystal forms known as allotropes. These allotropes change with temperature and pressure, so plutonium can be brittle in one form and more malleable in another. Radioactively, plutonium primarily emits alpha particles. Alpha radiation can be stopped by paper or skin, but the real danger is if plutonium is inhaled or ingested. Then the alpha particles absorbed into and destroy the living tissue. Different isotopes of plutonium behave differently. Some give off significant heat as they decay, and others remain radioactive for thousands of years. Visually, it tarnishes and forms oxides in air like other reactive metals. Plutonium was first created and identified in 1940 at the University of California, Berkeley. A team led by chemists including Glenn T. Seaborg and his colleagues produced a new isotope by irradiating uranium, then chemically separating out the unfamiliar atoms. After gathering enough of it, it could be condensed into a metal, creating the first man-made element visible with the naked eye. They named the new element plutonium, following the planetary naming pattern after uranium and neptunium. This discovery was later turned into the Manhattan Project, the first major step in nuclear weapons. The first bomb dropped on Hiroshima was a uranium bomb, the Little Boy, but the second bomb was an implosion-based plutonium bomb named the Fat Man, as pictured. Plutonium is not the safest material to be working with. It emits alpha radiation, meaning the main health risk is internal contamination. If tiny particles are inhaled or swallowed, the alpha radiation can damage cells over long periods, increasing cancer risk. Some isotopes also produce small amounts of gamma and neutron radiation, increasing this risk. Any plutonium ingested does not filter out of the body and has a fatal dose of just 1 microgram. Environmentally, plutonium binds to soils and sediments and can persist for long times, and some isotopes have very long half-lives, being 80,000 years. There's also the nuclear safety danger. Certain isotopes, notably plutonium-239, are fissile, meaning they can sustain a nuclear chain reaction. For these reasons, it's pretty difficult for an average person to obtain any plutonium. Most plutonium in the world is produced in nuclear reactors. Ordinary uranium-238 atoms in reactor fuel absorb neutrons and through nuclear transformations become plutonium isotopes. In commercial settings, when fuel is taken out of a reactor, some plutonium will be present mixed with other radioactive materials and fission products. To recover plutonium for reuse chemical separation processes, are used to separate plutonium from spent nuclear fuel. These operations are done in highly specialized labs due to the dangerous nature of this work. Because of the security and non-proliferation issues, access and technical specifics are strictly controlled internationally. Plutonium's applications are for both civilian and military work. On the military side, certain isotopes are used as nuclear weapons, and this is what most people associate plutonium with. Civilians use plutonium in a few specialized and important ways. Plutonium-238 generates heat as it decays, and the heat is converted into electricity in a machine called a radioisotope thermoelectric generator. These have powered the deep space probes where other fuel sources were not practical. Plutonium recovered from spent fuel can be blended with uranium to make new fuel and is used in reactors, recycling some energy content. And small amounts are still used in research on materials, reactors, and in isotope science. In conclusion, plutonium is a material that is still being researched today. Historically, it was only discovered 80 years ago, making it one of our newer elements, but practically, it powers spacecraft, recycles energies in reactors, and due to its danger, demands government oversight. It started off making bombs, but now it's making energy. Here are my sources. Thank you.